Guys, and welcome to week 2 of distance learning. Um, this week is the first week we're going to talk about something a little bit new. It's actually an extension of something we've already talked about, just adding another wrinkle to it. But it is something that we need to cover. We'll talk about this this week and next week, and then we'll finish up the last unit, the last 4 weeks that we're together. So today we're going to talk about geometric sequences. We've already talked about algebraic sequences a little bit earlier in the year. So we're just going to add, just like geometry is the next class that you're going to take after Algebra 1, geometric sequences is the next step in sequences after algebraic sequences. Now, if you'll remember, algebraic sequences, a sequence is just a sequence of numbers that there is a common theme with. Okay, so let's take the easiest one we can think of. Let's say 2, 4, 6, 8, the even numbers. That's a sequence of numbers. That's an algebraic sequence because we're adding 2 to the number before to get the next number. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. So 2, 4, 6, 8 is an algebraic sequence. Now, what we learned earlier in the year is we can find out using the recursive rule the 158th number in that same algebraic sequence. And the recursive rule, if you remember, is, let me write it down right here. It was A plus D times n minus 1, where A was our first number, D was our common difference, and remember the common difference is just the number that we're adding every single time to make the sequence, and then N was the numbered term that we're looking for. Okay, so A is the first number, D is the common difference, or the number that we're adding every single time, and N was the numbered term that we were looking for. Okay, so using this recursive rule right here, we can find the 158th term in 2, 4, 6, 8 sequence. Okay, so the first number in that sequence we started with was 2. Okay, so we write 2 as our A, plus our common difference is also 2, because that's the number we're adding every single time. So we have 2 plus 2 times, and then n minus 1, remember n is the number term we're looking for, so we're looking for the 158th term, so we do 158 minus 1. So this would be the recursive rule for finding the 158th term. Okay, and when we do that on a calculator, we do PEMDAS, so 158 minus 1 is 157. So then we have 2 plus 2 times 157. 2 times 157 is 314 plus 2. So then we have 316 would be the 158th term in that sequence that starts 2, 4, 6, 8. Okay, so hopefully that's a little bit of a refresher. We may have an assignment on this a little bit later as a part of our review. But today what we're going to talk about is geometric sequences. The only difference, it's still a sequence is still a number that has something in common with all the other numbers. However, instead of adding the numbers, we added 2 to 2 to get 4, and then 4 plus 2 is 6, and 6 plus 2 is 8. With geometric sequences, instead of adding the numbers, we actually multiply the first number by a number to get the next number. Okay, so an example of a geometric sequence very similar to this algebraic sequence, and I'll leave that on there, would be 2, 4, 8, 16. This would be an example of a geometric sequence. Okay, the first one was 2, 4, 6, 8. This is an algebraic sequence because we're adding the numbers. This is a geometric sequence because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So a slight difference. Now, I'm going to show you the recursive rule for geometric sequences as well. And it's very, very similar to the recursive rule with algebraic sequences. We just use another operation, just like we go from addition to multiplication here for our sequences. In our recursive rule, we go from multiplying our common difference times the term we're looking for to actually using an exponent, which we've talked about a little bit before we went on break. Okay, so let me write down the recursive rule for geometric sequences. What you do is you multiply our a, our first number, times r, which I'll explain a little bit later, and then we raise that r to the n minus 1 power. Okay, so this is the recursive rule for a geometric sequence. This is the recursive rule for an algebraic sequence. So you'll notice we had a plus, and then our common difference, and then times n minus 1. In this we have a times r, and then we're raising it to an exponent instead of multiplying. Okay, so one difference, okay? A is still the same. A is still our first number. And n is still the numbered term we're looking for. So in the same way, we do a and n stand for the same thing. Now you'll notice in the algebraic rule we had d, and in the geometric sequence we have r. That's because we do something different to find them. Okay, r stands for, instead of the common difference, we have the common ratio. Now just a little bit of a refresher. Remember, difference means we subtract, right? And to find the common difference in an algebraic sequence, what we do is we take one of our terms in our sequence and we subtract the number that's right before it. Okay, that's why it's called the common difference, because difference means we subtract. In our geometric sequence, what we're going to do, what the term ratio means, is divide. A ratio is just a fraction, which means we're dividing. So instead of subtracting one number minus the number in front of it, to find the common ratio in a geometric series, all we do is we pick any of the numbers. We can pick 16, we can pick 8, we can pick 4. It doesn't matter. They're all going to have the same common ratio. So I can do 16 divided by 8. Plug that into my calculator if I need to. 16 divided by 8 is 2. 8 divided by 4, still 2. 4 divided by 2, 2. Okay, so our common ratio in this geometric sequence is 2, because that's the number that's being multiplied by the first term to get the next term. And then we're multiplying 4 times 2 to get 8, and then 8 times 2 to get 16. Okay, so the common ratio is just a math term for the number that we're multiplying every single one of our numbers to get the next number in the sequence. So let's say with this sequence 2, 4, 8, 16, I want to find out what the 7th term is. Okay, so all I do is I write my recursive rule, which is a, which is my first number. My first number was 2, times my common ratio, the number that's being multiplied every single time, which is also 2, and then I raise that 2 to the n minus 1 power. So I'm going to do 7 minus 1. Okay? So that's what that looks like. So then again, I do PEMDAS. I have to simplify my exponent first, and then do the exponent, and then multiply. Okay? So 7 minus 1 is 6, so I have 2 times 2 to the 6th. Okay? Let's think about what 2 to the 6th is. It's just 2 times 2 times 2 6 times, right? So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 to the 4th power is 16. So we got to keep going until we get to the 6th. So 16 times 2 is 32. And then 32 times 2 is 64. So 2 to the 6th power is 64. So we have 2 times 64. And 2 times 64 is 128. So the 7th term in this sequence is going to be 128. And we could multiply this out. This is the first term, second term, third term, fourth term. So then the 5th term would be 32. Sixth term would be 64. And the seventh term would be 128. Okay, so that's how geometric sequences work. Now, just a reminder, on your homework today and this week for target number 3, the first several questions, all they're asking you for is to find the common ratio found in the geometric sequences that they give you. All you do to find the common ratio of any geometric series is pick any of the numbers. I usually use some of the first numbers because they're smaller numbers, and I like to use small numbers rather than big numbers. But then you divide that number by the number right in front of it. You can use a calculator. Let's say the sequence starts 10, 40, 1600, whatever. Okay, then you would divide 40 by 10. 40 divided by 10 is 4. So we're multiplying everything by 4, so the common ratio would be 4. Okay, something to look out for. If your numbers alternate between positive and negative numbers, what does that probably mean about your common ratio? Well, think about it logically. What's a positive number times a negative number? That would be a negative, so the next number would be negative, but then a negative times a negative is a positive, so the next number in the sequence would be positive. So if your numbers are alternating back and forth between positive and negative, that means that your common ratio is also negative to make those numbers go back and forth, because a negative times a negative is a positive. So all you do, again, to find the common ratio is divide one of the numbers by the number that's right in front of it in the sequence. Okay, so that means we can't use the first number, but we can use the second number divided by the first number. Excuse me. Now, the second part of your homework just asks you to find, like, the sixth. They give you a sequence, and they ask you to find the 6th term, or the 8th term, or the 17th term, or whatever. And all you do is you use this right here. You put the first number as your A. You're going to have to find the common ratio because they're not going to give it to you. So you go ahead and divide it just like you did on the first several problems. Divide one of the numbers by the number right in front of it to find the common ratio. And then you raise the power, and you can use a calculator to do that. And I'll put a calculator on your Chromebook. There's a link that you'll be able to access on the main page in order to be able to have a calculator on your Chromebook if you don't have one that'll do exponents at your house. So all that is pretty straightforward, pretty simple. That's all there is to the new content for this week. Now, as far as the review, they're just simply multi-step problems. So multi-step equations. So remember, to solve a multi-step equation, all we do is we're looking to get the variable by itself. So whatever number is added or subtracted to the x or the a or the p or whatever our variable is, we add or subtract that, do the opposite to move it to the other side, and then we multiply, divide, and so on and so forth in order to get things by themselves. Okay, so again, we'll probably be having a Google Hangout this afternoon at 1 to answer any questions you have. Since we have new curriculum, we'll also be having a Google Hangout on Wednesday to give you a little more time to chew on this stuff and to look over it and to have some more questions. So 1 o'clock both today, on Monday, and Wednesday, we will have Google Hangouts so that I can answer any of your questions. Those links will be in the agenda on Oasis if you need them. So look forward to seeing you guys. Hopefully you do well on this assignment, and look forward to seeing you.